So here, what does this Green's theorem will tell is nothing but whenever your integral is of the form m dx plus n dy, then this can also be written in terms of double integral dou n by dou x minus dou m by dou y into dx dy. Okay, so you can perform this integral and you can get the answer. Okay, so where m and n are the functions of xy. Okay, functions of xy or xyz also. Okay, so let us see how to solve this. The basic thing in the Green's theorem is you have to satisfy this theorem. Okay, so that means line integral will be equal to surface integral like this. Okay, so let us see how to solve a problem based on this. Okay, let us see this theorem. We need to verify Green's theorem for this one. Okay, so before applying double integral or surface integral, first we will solve this integration using this one, line integration. Okay, by applying like previous problem as we did in the last class, right? How we have solved line integral over some particular curve. So in the same way we are going to do this. Okay, so first let us write what is f dot r. Okay, here f dot r is nothing but the integrand. Okay, after integral what and all is there, that is called the integrand. So this is nothing but f dot dr is equal to 3x square minus 8y square into dx plus 4y minus 6xy into dy. Okay, so we need to find the integral value of this over these curves. Okay, given curves are so what are those given curves? Y equal to root x is one curve. Similarly, y equal to x square is one curve. Okay, so this is nothing but this can also be written as, if you square on both sides for this equation, y square equal to x, y equal to x square. Okay, so you need to find the integral value through these two curves. Okay, so let us see how to solve this. Before going to that, we need to find the common point between these two. Okay, so let us see. Let us draw these two curves. How to draw y equal to x square curve? This will be like this, right? It's a parabola. The curve will be like this. Okay. Similarly, x equal to y square. X equal to y square will be like this. Okay. So this is y equal to x square and this one is y square equal to x. Okay. So if I take this point as origin O and this as intersection point A. Okay, we need to find what is this point. Okay, how to get this intersection point? Okay, so I'll find the intersection point. Intersection point of above curves. Is how to do? You have to substitute any one equation into this. Okay, this equation into this or this equation into this. Okay, so I am taking y equal to x square in this equation. So what happens? Y equal to x square, if you put x square whole square is equal to x you got. That means the second equation I have substituted in first equation. Okay. So in the place of y I have substituted x square whole square is there equal to this value is x. Okay. So that means x power 4 value will be x. So one x get cancelled implies x cube must be equal to 1 implies x must be equal to cubed root of 1. So 1 power anything is 1. Okay. So implies x value will be 1. Okay. If you substitute x equal to 1 in any of these two equations. Okay. So substitute x equal to 1 in y square is equal to 1. Okay. So implies what happens? Sorry, y square is equal to x. So y will be equal to root x. Implies y equal to, if you substitute x value root 1, it is 1. So when x equal to 1, you got 1 y equal to 1. Therefore, the intersection point is what is it? 1 comma 1. So what is this 1 comma 1 is nothing but a point. So 1 comma 1. Okay. Now we have to do integration along this curve. That means we are going to find area between these two. Okay. So this area we are going to find. Okay. How will you find? Means using line integrals. Okay. So first I will calculate the integration along this curve. So what is this curve? Y equal to x square. Okay. Sorry. Okay. Along this curve. So I'll write integration along OA. That is nothing but y equal to x square. Okay. So here I am going to substitute y equal to x square implies differentiate with respect to x. What happens? Because in f dot dr we are having dx dy is there. So since we are taking y equal to x square, we need to find dy value also. Okay. So for that sake, I have to differentiate with respect to x. Dy by dx is equal to 2x you'll get. Implies what will be value of dy is equal to 2x dx. Okay. So when y equal to x square, we got dy value as 2x dx. Now substitute these two values in, you can take this as equation 1, f dot dr. Okay, implies f dot dr is equal to, substitute this y value, how much you'll get? 3x square minus 8 into y square. Y square means x square whole square into dx is there, I have to write dx plus 4y. So 4x square minus 6xy. 6 into x y value, x square into dy. So dy value is 2x dx. Okay. So implies, how we got this? Since from equation 1. Okay. So implies f dot dr is equal to, how much you'll get? 3x square minus 8x power 4, okay, plus 4x square into 2x. We'll get 8x cube. Next, minus x cube into x power 4. So 12x power 4. Okay, 12x power 4. I'm taking dx common. So you can write dx like this. Implies f dot dr is equal to, how much you'll get? 3x square plus 8x cube minus minus 8 to minus 12, because x power 4 terms are 2. So I'll get minus 20 x power 4 into dx. Now apply integration on both sides, because you have converted f dot dr in terms of x. So apply integration on both sides. Okay, so implies integral f dot dr is equal to integral of 3x square plus 8x cube minus 20x power 4 dx. Okay, so we'll integrate it. How much you'll get? So integral f dot dr along OA. So what will be the limits for x? So through origin, so 0, 0, 0 to 1 you'll get. So 0 to 1. Okay, so integral 0 to 1. So just write it as it is. So integration of x square is x cube by 3. So you'll get 3 x cube by 3. Next 8 x power 4 by 4 minus 20 x power 5 by 5. Having the limits 0 to 1. So this one is equal to 3 get cancelled, 4 1s, 4 2s, next 5 1s, 5 4s. Okay, again substitute x equal to 1 as upper limit. How much you'll get? 1 cube plus 2 into 1 power 4 minus 4 into 1 power 5. So this one equal to how much you'll get?
Minus 1.
You'll get minus 1. Okay, so integration f dot dr over OA curve. You got it as minus 1. So take it as equation 2. Okay. Similarly, we will find integration along this curve, AO. Okay. AO means x equal to y square. Okay. So integration along AO curve. So which is nothing but x equal to y square. Okay. So if x is equal to y square, implies you need to find dx value. So differentiate this one with respect to y. What happens? Dx by dy you'll get is equal to, what happens? 2y, because you are integrated, differentiated with respect to y. So dx is equal to 2y dy. So that means in this equation we are converted x values in terms of y. Okay. So implies from equation 1 f dot dr is equal to, what is that equation 1? 3x square minus 8y square. So 3 into x square. X square means y square whole square.
Sir, why do you have to integrate again along AO?
Huh? AO means this
Why
is a
do you
different curve, right? AO means this is different curve. This is x equal to y square. Previously we did y equal to x square. Along this curve we have integrated. Okay. Now from AO is nothing but this curve we are using. X equal
Both
to
the
y
curves
square.
we have to do.
Both the curves we have to do. That is what he is asked now. Verify the Green's theorem in the plane over the integral when C is the boundary of the region enclosed by y equal to root x, that means x equal to y square, and y equal to x square. Both the curves you have to do. Clear? So 3x square means 3y square whole square, next minus 8y square into dx value. Dx value is 2y dy minus 4y minus 6xy. 4y minus 6 into y square into y into dy. Okay. So just simplify this. How much you'll get? 3y power 4 minus 8. We have to multiply with 2y here. So 2 into 3, 6. Y power 4 into y, you'll get y power 5 minus 8 into 2, 16. Y square into y, you'll get y cube minus 4. 4y minus of minus plus 6y cube. Yeah, plus. Okay. So into dy. So implies integral f dot dr over the curve AO is equal to integration of what is the limits for AO curve. Here direction also very important.
1 to 0.
1 to 0. Yes, correct. So 1 to 0. Lower limit is 1, upper limit is 0. Okay. So f dot dr value we got it as how much? 6 y power 5. So minus 16 y cube plus 6 y cube. So you'll get minus 10 y cube. Okay. Next minus 4y into dy. So do the integration. How much you'll get? Or you can take this one as reverse. Okay. Whenever you are taking the limits as reverse, you have to multiply with minus. 0. Integral minus if you are taking, so 0 to 1 it will be converted. 6y cube minus y cube minus 6y power 5 minus 4y into dy. So this one is equal to, so whenever you multiply with minus, here what happens, limits will get interchanged. Okay. So how much will get? Minus of integration of this 6 into y power 6 by 6 minus 10 y power 4 by 4 minus 4 y square by 2. Limits are from 0 to 1. So multiply this minus inside, how much will get? These two get cancelled. 4 ones or 2 twos, 2 5s. Okay, 2 ones, 2 twos. So overall how much will get? Minus of, if you multiply with minus, how much will get? Minus 1 or minus y power 6 plus 5 by 2 y power 4 plus 2y square. 0 to 1. So do the integration, how much you'll get? Minus 1 plus 5 by 2 plus 2. So this one equal to how much? Minus 1 plus 2. You'll get 5 by 2 plus 1.
7 by 2.
You'll get 7 by 2. So this is integration along AO. F dot dr. Okay. So therefore, overall integration integral f dot dr is equal to integration along OA direction f dot dr plus integration OA f dot dr. Okay, if you take this as equation 2 and this as equation 3, from equation 2 and 3, how much you'll get? Minus 1 plus 7 by 2. So answer is minus 2 plus 5. Sorry, minus 2 plus 7 will get 5. So 5 by 2 is the answer. So integration over the given curve f dot dr is equal to 5 by 2. Got it? Finally, we have to add these two individual curves. Integration over these two curves. So you'll get 5 by 2. Clear? Is it fine?
Sir, in both of the limit you have written OA, sir. One is AO, no?
Yes. Here AO. OA plus AO. But still problem is there. Okay. So this much you got using line integral. Okay. But what we need to do? What is the question? Verify the Green's theorem. That means we have to verify the Green's theorem. This we have done through line integral. But the same thing you have to do by double integral, and we have to show that that integration value also 5 by 2. Okay, so let us see that. So here by Green's theorem, so what does the Green's theorem will tell? Integral m dx plus n dy is equal to double integral over a region R. So this is around some curve C. Dou m by dou y. Sorry. Dou n by dou x minus dou m by dou y into dx dy. So this value we need to find now. Okay, how will you find? Means first we need to find what is m and what is n. Okay, so given, or you can write from equation 1. So let us see what is that equation 1. So this is equation 1. Okay, so f dot dr, this is equation 1. From this dx quotient you have to take. So dx quotient is 3x square minus 8y square. So dx quotient here is m is equal to 3x square minus 8y square, comma, n value is dy quotient. So dy quotient is 4y minus 6xy. 4y minus 6xy. Okay, so you got m value and n value. Find out dou m by dou y and dou n by dou x. Implies dou m by dou y minus dou n by dou x is equal to or you can write first find dou n by dou y. So you'll get minus 16y. Correct. Dou n by dou x minus 6y from this. Okay. So implies dou n by dou x minus dou m by dou y is equal to minus 6y plus 16y. Correct. Or you can write minus 6y is the value of dou n by dou x minus of minus 16y. So minus 6y plus 16y. So this one is equal to how much? 10y. Okay. Now we need to integrate this 10y. So implies double integral of over the region R dou n by dou x minus dou m by dou y dx dy is equal to double integral 10y. Okay. So here y is there. Better if you do integration first with y. So I'll write dy dx. That is your wish. Whether you want to do integration first with respect to x, then with respect to y, or first with respect to y, or then with respect to x. Answer won't change. Okay. Since the y variable is there, first let it be, I will banish y variable. So for that sake, I have written dy here. Okay. So we need to find these limits. How to find these limits means rewrite the diagram which we have taken here. Okay. So while doing line integration, what we did, we have drawn, this is y equal to x square and this is x equal to y square. Okay. This point is 1 comma 1. Okay. So outer integral is what? Dx, right? So for outer integral, limits will be in terms of numbers, right? So here 0 comma 0 is there, origin. This is started at origin and ended at this point. In this point, where does x varies from? 0 to 1, right? So that means 0 to 1. X ranges from 0 to 1. So whenever you are taking x or dx value, so that means you are thinking in horizontal manner. Okay. Now whenever you want to find the limits for dy, you have to think in vertical manner. Okay. In vertical manner, if you observe like this, what is the first curve coming across to you?
Y equal to x square.
Y equal to x square, right? So you have to write that y equal to x square here. First. Next, last curve here. What is this curve? X equal to y square. X equal to y square means y equal to?
Root x.
You have to write root x here. So in this way, you have to write the limits. Clear? Any doubts in writing the limits? Clarify it now itself. Any doubts? Whenever you are taking dx, means you are taking in horizontal manner. Whenever you are thinking of dy, you are thinking in vertical direction. Okay. So if you remember these points, then writing the limits is very easy. Okay. So this one is equal to, we'll perform the integration now, is equal to integral 0 to 1 10y. So this 10 I am writing outside. Integration of y means y square by 2. Okay, having the limits x square root x dx. So dy get 1 is 2. So 10 by 2. This 2 also I am writing here. So integration of y square is there. So 0 to 1. Apply the limits first. So root x whole square. So this is nothing but x minus x square whole square. You'll get x power 4. Okay. So dx. So this one is equal to 5 into how much you got? Integration of x is x square by 2
By
minus x
minus
power
x
5 by
4 5.
x power 5 by 5.
5.
0 to 1. Okay. So this one is equal to 5 into
1 by 2
apply the
minus 1 by
limits.
5.
1 by 2 minus 1 by 5. So what is the LCM? 5 into 5 minus 2 by 10. Okay. So what is 5 by 2? Sorry, 5 minus 2?
3 by 10.
3 by 10.
5 into
3.
3 by 10.
5 into 3 by 10. So 5 ones, 5 twos.
3 by 2.
3 by 2. Here how much you got? 5 by 2. Wait. You should get the same answer. What is the first integral value?
Sir, you have taken minus here.
Where?
2y dy minus. It is plus, no, sir.
2y?
On the
Sir,
left
from
side.
equation 1 here, left side. Down.
Down, okay.
On the left side.
Not that, sir. Left side.
Okay.
Here. Plus it is there in question. After 2y dy, it must be plus.
This is plus, okay.
Yes, sir.
So you'll get plus here minus. Wait a minute. Yes. Here only we did mistake here. So here how much you'll get? 22, right? 22 y cube plus 6 power 5. This also plus. This also plus. So here I have to write 22 here by 4. This is plus. Okay. So here 11 you'll get. So 11 by 2. This also minus. Okay. So whenever you are multiplying with minus, this will become plus. So you'll get here 11 by 2 minus 2. So you'll get minus 3.
What is happening, sir?
Wait. Here we have taken minus. I have taken previously. I made it plus. So what happens? Minus 16y cube minus 6y cube. So minus 16 plus 6, 22, right? Minus 16 plus 6. So that's why I have written 22 here. So 22 I have integrated 22y cube. So I'll get y power 4 by 4. So 2 twos, 2 11s. So 11 by 2 I have converted. Now substituted 1 again. So how much you'll get? Minus 1 plus 11 by 2 minus 3. So minus 3 plus 11 by 2 you got. So minus 3 plus 11 by 2, how much? 5 by 2 here. Okay. So 5 by 2. If you substitute 5 by 2 here, 3 by 2 will be the answer. Now you'll get 3 by 2. Here also 3 by 2. Clear? So I will change the ink so that you'll get clarity in this. So what I did is, here I should have minus. Sorry, here it should be plus. In the previously I have taken minus here. So that's why I got wrong answer. So now here I have taken plus. So this will be minus as it is. This and this I have added. Okay. So the changes made is here. Previously I was having 10y cube. But here minus y cube minus 6y cube. Minus 16 minus 6 will get minus 22. So that only I have written here. Okay. When you are taking a minus, you have to change the limits, right? So 1 to 0 is there, 0 to 1 it has converted. Okay. Now I have applied integration. Okay. And I have multiplied with minus. So all the plus term will become minus. Minus term will become plus. So that means middle term will be plus. Okay. So again substitute y equal to 1 here. How much will get? Minus 1 power 6 minus 1 plus 11 by 2 1 power 4. Next minus 2 into 1 square. So this much will get. So minus 1 minus 2 means minus 3 plus 11 by 2. So if you take LCM, how much will get? Minus 6 plus 11. So you'll get 5 by 2. Okay. So I have substituted that value here. So minus 1 plus 5 by 2. What is this minus 1? This is from this equation. OA direction. Okay. From this I have taken. Minus 1 plus 5 by 2. We got 3 by 2. So this is the answer actually. 3 by 2 is the answer. Next, we have performed the same integration using double integrals. Here also we got 3 by 2. So double integral dou n by dou x minus dou m by dou y dx dy. Okay, that means hence Green's theorem is verified. So here limit how I have taken is, first I'll write double integral 10y dy dx. Okay, so this can be your wish. Okay, based on this the limits will change. Okay, so I can write this as dx dy. This also you can find, or dy dx. This also will be running, no problem. Okay, so what I did is outer integral I have checked. What is outer integral? Dx. So dx means in horizontal way I have to think. Okay, in horizontal way, where does x move from? Okay, in the first point this is 0 and in the last point it is 1. Okay, so that means limits ranges, x ranges from 0 to 1. Clear? This is clear. Along dx means horizontal direction. In horizontal direction, where does x move from in terms of numbers? Okay, so that means 0 to 1. Okay. Similarly, when you are taking dy, you have to think in vertical way. Okay. In vertical way, what is the first curve you are getting? Okay. What is this curve? This is y equal to x square, right? So that's why I have written y equal to x square here. Next curve, where does it ending? Here it is ending. So that means This is root x curve. So in this way you have to write the limits. Okay, suppose I don't want to take like this. I want to take like this. Double integral 10y dx dy I am taking. Okay, how to write the limits for this? Okay, now what is the outer limit? You have to check. Here dy is there. So that means first you have to think in vertical manner. In terms of numbers you have to write the limits. Okay, so in vertical manner, where does y value ranging from? Here in the first point it is 0 and in the last point it is 1. So again y value ranging from 0 to 1. Okay. Getting clarity? Okay. Next, second one, dx. So dx means in horizontal manner you have to check. Okay. In horizontal manner, what is this curve? First curve? X equal to y square, right? Okay. So x you have to write in terms of y. So that means y square will get here. Next, where does it ending? This is ending at this curve. Okay. So what is this curve? Y equal to x square. X in terms of y you have to write it. So that means root y you will get. So whenever you are writing with respect to dx dy, then you have to write y square to root y. When you are writing dy dx, then the limits will be x square to root x. So if you want to check the answer, like this also you will get the same answer. If you want, you can verify. So integral 0 to 1, 10y into x. Okay, where x ranges from y square to root y. Okay, so this one is equal to integral 0 to 1, 10y into root y will get minus y square dy. Okay, so if you simplify this, how much will get? Integral 0 to 1, 10 into y power 3 by 2 will get. If you multiply with y, minus y cube. Okay, dy. So I am continuing here. So if you integrate, what happens? 10 into y power 3 by 2 plus 1. 3 by 2 plus 1 means 5 by 2 will get. Here also 5 by 2 divided by 5 by 2 minus y power 4 by 4. Okay, so multiply with 10 now, having the limit 0 to 1. So if you multiply with 10, so 10 into 2 by 5, y power 5 by 2 minus 10 by 4, y power 4. Okay, having the limits 0 to 1. So this one is equal to 5 ones, 5 twos. Okay, 2 into 2, 4 will get. 1 power anything is 1. So 4 minus 2 ones, 2 twos. Okay, so how much will get? 2 by 2 5s, right? Is 2 5. So 2 twos, 2 5s. 2 twos, 2 5s. So I'll get 5 by 2 here. Okay, so what is the LCM? 8 minus 5 by 2. So what is the answer? 3 by 2. In this way also you got 3 by 2. Here also you got 3 by 2.